Okay. Charge density. So you're going to get Q over, and then the density is or the volume is 4/3 pi r cubed. So this becomes 2.39 times 10 to the minus 6. And that's going to be coulombs per cubic meter. Oh. If density is this equation, then it's going to be density. So then all I need is the volume at 5, right? So because Q is going to be this times density, or density times volume of 5, density in the volume of 10, and density of volume of. So this is obviously going to be like 1 times 10 to the minus 8. It's going to be 8 times 10 to the minus 8, something like that. But we're just rounding it off and putting it in nanocoulombs just as an exercise of unit conversion. So for part C, we said Gauss's law says the flux is something like EA, and then that equals Q over E0. So if we know the amount of charge, what we can say here is that E is going to equal to Q over A E0. That EA is Q over E0. And then some questions that came up, some people are saying, hey, why don't you just use this? E is K, Q, G. Q, well, let's take a look at this. If we say E is Q over A, E0, and then what is A? That's going to be Q over 4/3, oh, just kidding, earlier they got me, 4 pi E0. And hopefully we all remember that K is equal to 1 over 4 pi E0. So that gives me, from this, KQ over R squared. So I'm not recording that. So yeah, these things come out to be the same. So for part C, we're just using this sort of derivation of Gauss's law. We're just saying we have these 3 Q's, and then we know the areas at each of the given parts of the question. So again, just take the charges, these 3 charges, 1, 2, 3, and use them with the areas that are calculated at the radii of 5, 10, and 20, and you'll get these 3 numbers, 45, 9,000, and 8. Now, I thought when you get farther and farther away from a shape,